When we talk physics, it's easy to jump to black holes and, the really big, like, mysteries of the universe.
Right.
But this year's Nobel Prize is a good reminder that physics is also shaping something we experience every single day.
Yeah, absolutely.
Learning.
Yeah.
And more specifically, how we can get machines to learn using artificial neural networks. So that's what we're diving into today.
Yeah.
The fascinating work of John Hopfield and Jeffrey Hinton.
It is amazing to think that we can draw inspiration from, the human brain,
Yeah.
which is arguably the most complex structure that we know of,
For sure.
and use it to create machines that can learn and adapt.
It's pretty wild.
Yeah.
So for those who are maybe just joining us, can you break down what these artificial neural networks actually are?
Sure. So imagine a network of interconnected nodes, almost like a digital web, right?
Okay.
Each of these nodes receives information, it transmits information, and the connections between them, they can actually strengthen or weaken based on the data that they process. It's basically a simplified model of how neurons in our own brains interact and learn.
So it's like taking that physical world of connections and
Yeah.
applying it to this, intangible concept of learning.
Precisely. And that's actually where John Hopfield's work comes in.
Okay.
So back in the 1980s, he developed something called the Hopfield network.
Okay.
And this elegantly uses principles from physics, especially the behavior of tiny magnets, to create a network that can actually store and reconstruct patterns.
So is that kind of like giving a computer a puzzle that's all fragmented and has to put it back together?
Yeah, that's actually a really good analogy. Think about restoring a damaged photograph, right?
Yeah.
You feed the network this blurry or incomplete image. It uses its understanding of patterns that it's learned to fix the image by finding the closest matching memory it has stored.
Oh, wow.
And this ability to associate the input with these stored patterns is why it's called an associative memory.
So Hopfield essentially found a way for computers to mimic that very human ability to learn and recall patterns.
Yeah, absolutely. He really provided that foundational framework, and then came Jeffrey Hinton,
Okay.
who took that framework and just propelled it forward with his invention of the Boltzmann machine.
The Boltzmann machine.
Right.
Sounds impressive. What is it about that makes it so different than the Hopfield network?
Well, imagine going from recognizing shapes to deciphering these really complex images
Okay.
with remarkable accuracy.
Right.
The Boltzmann machine, it kind of adds this whole other layer of sophistication by drawing upon, principles of statistical physics.
Statistical physics. Okay, now that sounds like a whole nother deep dive.
Yeah.
But how does that play into teaching, computers how to learn?
Well, so think about it this way. Statistical physics, it helps us understand how systems with tons of interacting elements, like gas molecules in a room, right? How they behave. And Hinton's genius was in realizing that this same framework, you can apply it to training neural networks.
Interesting.
So by analyzing these huge data sets, kind of like how physicists study the interactions of countless particles,
Right.
the Boltzmann machine can identify and learn these super intricate patterns way better than anything before.
So he basically took a page from the book of nature.
Yeah.
How
Yeah.
complexity comes from these simple interactions, but on a massive scale.
Exactly.
And then applied it to, the digital world.
Exactly. And the implications are what we're seeing all around us today.
Right.
The Boltzmann machine, with its ability to learn these really complex patterns from data, that's the foundation for all this machine learning stuff we see.
So something that seems as straightforward as teaching a computer to, recognize a cat in a photo
Right, right.
can actually have these huge implications.
Yeah.
What are some other ways that that's, playing out in the world today?
Oh, man. Think about self-driving cars, right? Yeah.
Navigating these crazy streets, facial recognition software that tags your friends instantly,
Yeah.
even personalized recommendations on Netflix, Spotify, whatever you use.
Oh, right.
All those things, they rely on algorithms.
Okay.
That really came from the work of Hopfield and Hinton.
It's they gave us the tools, and now it's just this huge explosion of,
It's crazy.
advancements.
Yeah, totally.
And it's not even just limited to the digital world. We were talking earlier about, physicists using AI to design new materials.
Right, exactly.
I mean, that's another area where their work is having a major impact.
For sure.
That just sounds like something straight out of a sci-fi book. You know what I mean?
Yeah.
Before we started, if you told me we were going to be talking about using AI to design materials,
Right.
I would have thought we were like 100 years in the future, you know?
Yeah. Yeah.
But it's happening now, which is crazy. It's pretty amazing. And it just like shows you how important like fundamental research is.
Right.
Because Hopfield and Hinton, they weren't trying to design materials.
Right.
But, their work on these networks is having this like ripple effect across all these different fields.
So how does it actually work? Do we like feed a computer a bunch of equations and then it just like spits out blueprints for a new alloy or something?
Well, it's not quite that simple,
Okay.
but the general idea is pretty cool. So imagine like this massive database or library,
Okay.
and it has everything we know about materials.
Okay.
Their atomic structures, their properties, how they behave, all of it.
Right.
And then you feed that to an AI.
So it's like reading this library and learning what makes a material strong or flexible or conductive
Exactly.
or whatever it needs to be.
It's learning those patterns, like
Yeah.
what connects a material structure to its properties.
Okay.
But here's where it gets really interesting. Once it's learned all that, it can start making predictions about materials that don't even exist. Hypothetical materials.
So like a scientist could say, I need a material that's super lightweight but also incredibly strong.
Exactly.
And the AI could like help them figure out how to make that happen.
Yeah, like at the atomic level, that's the goal. And we're already seeing some really promising results.
Wow.
I mean, this could totally change industries. Aerospace, energy, electronics. We could have lighter airplanes, more efficient solar panels,
Yeah.
even totally new computer chips, all because AI is like guiding us as we explore materials.
It's kind of mind-blowing to think that like we're on the verge of like custom designing materials, atom by atom,
Wild.
because of the work these two physicists did on the human brain.
It really shows you how, like, all this scientific knowledge, it's all connected.
Yeah.
And you never know what you're going to discover. I bet Hopfield and Hinton, they never imagined that their work would, like, revolutionize material science.
Right.
But here we are.
It makes you wonder what else is out there, right? Like
Yeah.
what other fields will be transformed by their discoveries.
And that's what's so cool about it. We're just getting started with AI.
It's really just the beginning.
The possibilities are, like, endless.
Well, that is certainly a lot to think about, but it's so fascinating to consider, and it's amazing to see these incredible advances in science. Thanks for joining us on this incredible deep dive into artificial neural networks and the groundbreaking work of this year's Nobel Prize winners. It's a story that I think really highlights the power of curiosity, exploration, and of course, the interconnectedness of scientific knowledge. Until next time, keep those questions coming and never stop learning.